In this lesson, we're going to go over slope fields, and we're going to understand how to sketch a slope field for a differential equation. We're going to understand and interpret a given slope field and match it to a differential function. And then we're going to sketch the particular solution of a differential equation on a slope field given an initial condition. So the first thing is, what is a differential equation? So it's any equation which contains derivatives. So here are three examples of differential equations. We can tell they're differential equations because they have derivatives. We have y prime and we have dy over dx. So it's really important that we remember dy over dx, or y prime, is the slope of a curve. So now we're going to look at how we can sketch slope fields. These are also called directional fields. Here are some steps that we can use to sketch them. So we want to plug the indicated points into the differential equation and solve for the slope. We want to make an x, y, dy over dx chart to keep track of our values. And then we want to sketch tick marks with appropriate slope on the indicated points. So this will make a lot more sense when we look at an example. So here we're given this differential equation. Dy over dx is equal to negative x over y. Sketch the slope field for the points indicated. So the first thing we want to do is set up our x, y, and dy over dx chart. When we're looking at these dots here, these are our indicated points. So we want to put a little slope, a little tick mark slope on each of these points. So we can kind of figure out a couple of things. We can see from this equation negative x over y. If I plug points in for x and y, that's going to equal dy over dx, which is the slope. So this is going to help us figure out the slope. By looking at this fraction, I can tell that when x is equal to 0, my dy over dx will equal 0, right? When the numerator of a fraction equals 0, the entire thing equals 0. When the denominator equals 0, that's where it's undefined. So by figuring out that information, I can kind of fill that in already. So I'm just going to make a little, note over here. So when x equals 0, dy over dx is going to equal 0. When y is equal to 0, dy over dx is going to be undefined. So when we're sketching slopes, remember that a slope of 0 means that it's horizontal, and a slope of undefined means that it's a vertical line. So I'm going to go on to my indicated points here, and anywhere where x is equal to 0, I'm going to draw in a slope of 0. So x is equal to 0 and on the points indicated here, only at 0, 1 and at 0, 2. So I'm just going to go ahead and make a horizontal line. So that's indicating that the slope here is 0. Similarly, when y is equal to 0, the slope is undefined. So that means that to draw my slope, it would be a vertical line. So anywhere where y is equal to 0, so that's going to be at negative 1, 0. So that's going to be a vertical line. At 1, 0, vertical line. At 2, 0, vertical line. So I can fill in that information here. Like I had 0, 1, and that's going to be 0. At 0, 2, that's also 0. At negative 1, 0, it was undefined. And at 1, 0, it's undefined. And at 2, 0, it's undefined. Okay, so with a lot of these, we'll be able to see patterns arising as well. So all we're going to do is just pick our remaining points. So we have, I'm just going to start over here. So 1, 1 is a point. So we're focusing on this point right here. So 1, 1, if I plug in 1, 1, 1 is x and 1 is y, this is going to equal negative 1. So that means at 1, 1, I have a slope of negative 1. So that's going to be something like that. Okay, and then I go on to my next point, and I'll just do 1, 2. So again, I'm going to plug them right into here. So negative 1 over 2, that's going to be negative 1/2. So I have another negative slope, but because it's negative 1/2, it's going to be a little less steep than negative 1, so maybe something like that. Okay, they don't need to be perfect, they don't need to be exact, they just have to be in the ballpark of where they should be. So then I'm going to keep going here, and I'm going to go to 2, 1. If I plug that in, that's going to equal -2. If I plug in 2, 2, that's going to give me -1. So let me just fill those in real quick. So -2 is going to be a little bit a steeper slope. So maybe like that. Then -1 again, that's going to be like a regular slope of 1. So there we go. And then we've got, I'm going to pick on the other side, the last two. So -1, 1 and -1, 2. So if I plug in -1 and 1, that's going to give me +1, -1 and 2, that's going to give me +1/2. So when I go to fill this in, I have +1 and then +1/2, maybe like that. So here's what my slope field is going to look like. So it's kind of tedious because you're picking points, but it's pretty easy in the fact where you're just plugging them in and getting values, and then you're just drawing little tick marks of that slope at that point. Okay, so we're going to look at this other example, and we're not going to do this entire thing because I think you guys can plug in things, but here we go. We'll start with our xy, and dy over dx. So we have another example with dy over dx is equal to -2x over y. Here's our indicated points. So on the AP exam, they will give you a graph with little dots, and those dots are the points that you need to make your little tick marks on. So again, we can kind of assume things from here. When x is 0, then when x is 0, dy over dx will be 0. When y is 0, dy over dx will be undefined. So I can tell that it's going to equal 0 when x is 0. So x is equal to 0 here, 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 and here. So I have those horizontal lines. And then if I were to pick points to plug it in, I would just pick a random point, like for instance 1, 1 again, and I would plug it into here, so I would get -2 over 1, so -2. So that's going to be a slope of -2, so something like that. So we're just going to kind of fill this in. We can also see that if x is going to be positive and y is going to be positive, then overall my slope will be negative. So when x is greater than 0 and y is greater than 0, I can tell that my dy over dx is going to be a negative value because I have a negative on the top and I'll have a positive on the bottom. So we can kind of see patterns as we go, and we can see that in certain quadrants we're going to have all positive slopes or all negative slopes based off of plugging in those points into the differential equation. So I'm just going to leave that example here, but we could keep going with it if we wanted to. So let's move on to a multiple choice question. So given the slope field, find the differential equation. So when we have the slope field given and we want to figure out which one this matches, what I would do is I would pick one of the slopes to focus on and then plug that point into each of the choices and see which one matches the slope. So for instance, I know this is a little bit of a weird coordinate plane. So if I were looking at, so here's 0, -2. So if I look at -1, 1, that's this point right here. Okay, so at -1, 1, my slope is 0. So -1, 1 is my point, and I know I have a slope of 0. Slope equals 0 because it's a horizontal line. So I'm going to check it in all of these. So if x is -1 and y is 1, and I plug it into here, this is going to give me -1, so 1 over 1, which is 1. So that is not equal to 0, so it can't be that answer. If I plug it into here, x is -1, so -1 minus 1, that's going to be -2. Again, that's not going to be 0. Plug it into here, 1 minus a -1, that's going to equal 2, not 0. Plug it into here, -1 plus 1, that does equal 0, but we got to check all of them first because sometimes you might get that 2 work for a particular point, and then you just need to pick another point and try it. So here I'll plug it in and I'll get -1 over 1, which is -1, which doesn't work. So our answer here would be D. Okay, so we're picking a point, we're plugging it in, and we're seeing what the slope is equal to, if it matches the slope of the slope field. Okay, another example, same type of idea. So I always focus on the slopes that are either undefined or equal to 0, because all the slopes that aren't undefined or 0 are hard to figure out exactly what the slope is. So I'm going to pick this point right here. So that's the point -1, 2. And I can tell that that slope is equal to 0. So I'm going to plug those in. So here I get -1 times 2. Well, that's not equal to 0. If I plug it into here, this is going to give me -1 times 2 minus 2. So -2 minus 2, not 0. Plug it into here. So -1 times 2 plus 2. So this is -2 plus 2. So that does work, but let's wait and see. So here we get -1 times 2 plus -1. So -2 minus 1, that's not equal to 0. And if I plug in -1 plus 1 cubed, okay, this does equal 0. So now I have C and E are two possible options. So what I need to do is then pick a different point. So now that I have this, I'll pick, maybe I'll pick 1, 0. So if I pick 1, 0, if I plug that into here, this is going to be 1 times 0 plus 0, which equals 0. If I plug it into here, 1 plus 1 is 2 cubed. That doesn't work. So our answer here is going to be C. Okay, and then the last part of this is being able to sketch a solution curve. So when we're sketching a solution curve, we want to draw in the given point that the solution curve passes through. We want to follow the shape of the slope field to fill in the curve on either side of the given point. And when we do that, we want to make sure that we continue our curve until the end of the grid. So if we stop with our curve and we don't continue it to the end of the grid, you won't get any credit for it on the AP exam. So we want to make sure that we draw it all the way out. So here's an example where we have a slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 0, 2, and then sketch the solution curve that passes through the point 1, 0. So first we're going to focus on 0, 2. So the first thing I'm going to do is at 0, 2, I'm going to, mark that. Okay, so from this point 0, 2, I want to fill in the solution curve. As I go to the right, all of the slopes are horizontal. So this is just going to stay horizontal. As I go to the left, again, they're all horizontal. So I'm just going to, stay horizontal. Pretend that that's straight. And notice that I went to the edge of my grid. If I stopped somewhere in the middle, it would not count. So we want to make sure we go to the edge. And then sketch the solution curve that passes through the point 1, 0. So here's 1, 0. I highlighted it on my graph. So now I'm following the solution curve. So as I go to the right, I can see that the slopes are going up and then they kind of level out a little bit. So that's going to the edge of the paper. I'm going to follow this here. So this is going to go this way. It becomes, again, pretend that that's somewhat decent. So it's going to follow the shape of the curve. So if the curve becomes 0, it follows that, and it's kind of like a boundary line, and it helps you figure out how this is graphed. Okay, and this last example, so the slope field for a certain differential equation is shown below. Which of the following could be a solution to the differential equation with the initial condition y of 0 equals 1? So y of 0 equals 1 is just the point 0, 1. So I'm going to go to 0, 1, plug that in there. Then I'm just going to follow the shape of this. So from the right hand side, it's going to go down like that. And from this left side, it's going to go like that as well. So I want to look at my answer choices and see which one matches. So cosine of x, that's going to be a trig function. And we know that that's going to look something like that, right? Here is a parabola that's upside down, so that's going to look something like this. E to the x is going to look like that. It's an exponential. This is going to be a semicircle, and then this is going to be a rational. So if we look at them, the only one that actually matches it is going to be E.